Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you have not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem is count all valid pickup and delivery options. Let's see what the problem is. We are given n orders. Each order consists in pickup and delivery service. Count all valid pickup delivery possible sequences such that delivery I is always after pickup. That is, first the item will be picked up and then only it will get delivered. So first pickup should be done and then only delivery should be done. Since the answer may be too large, return it modulo 10 raised to the power 9 plus 7. Fine. So see, n is equal to 1. So in the input we are given n is equal to 1. What does this mean? N is equal to 1 means there will be one item only. So one pickup, one delivery. So one P1 and this is delivery. So there could be only this, see there could be only this case for this, because we cannot do like this now. We cannot do D1 before P1 because it's given in the question that delivery will always be after pickup. So delivery cannot be before pickup, right? So this is not valid, hence only one permutation is possible for this case when n is 1. So let's see if n is 2. See, if n is 2 means there could be, let's see what all scenarios could be there. So that means we have P1, D1, P2, D2. Means these are, like you can say, these are two items, right? These are two items. First item is picked up and then it's delivered. Then second item is picked up and then it's delivered. We cannot do like this. We cannot first deliver and then pick, right? Obviously this is not the correct way. Or we cannot do like this also, that we are picking up the first item and then we are delivering the second item. This is also not possible because we have picked the first item. This second item cannot be delivered before it's picked up. So first it should be P2 and then only it should be D2. Fine. So see how many cases could be there for this, for two items. One case is this one. Other could be that first we are picking both the items and then we are delivering. Fine. Maybe we can do like this also, that we are picking first item, second item, we are delivering second item first and then delivering the first item. Or we can also do that we are first picking the second item and then we are picking the first item and then we are delivering the first item, then we are delivering the second item. Or what we can do is we can pick up the second item, pick up the first item, but we deliver the second item first and then the first item. Fine. And what could be another case? Another case could be that we are picking the second item, this variation of this one. We are picking the second item, we're delivering the second item, then we pick the first item and we deliver the first item. So these are your 6 cases, right? These are 6 cases which are possible. So output for this will be 6. 6. Fine. Now let's discuss for n is equal to 3. For n is equal to 3, output is 90. Fine. So let's see how it's 90. We'll not see all the cases obviously, but let's see how we can make. So see, for n is equal to 3, right? Means there will be P1, P2, P3 and there will be D1, D2 and D3. So these 6 things we need to arrange. Fine. Such that P1 should always come before D1, P2 should always come before D2 and P3 should always come before D3, right? This should be the cases. Fine. Now guys, see, if there is no such condition, right? If there is no such condition that D1 should always come after P1 like that, then though it's simple, right? If we have to arrange these 6 things, then how many ways are there? 6 into 5 into 4 into 3 into 2 into 1. That is, if we have to arrange these 6 items, 6 things, so there could be 6 factorial. That is n factorial. Whatever this, let's say this is like n is 6. If n is 6, here. So like if you have to arrange these 6 items together, then it will be 6 factorial, right? But see, that we do not have to do here. We have a condition that first pickup should be done, then only delivery should be done. If we follow this 6 factorial thing, na, 6 factorial thing, so a permutation for this could be this also, that d1 is coming first and then p1, something like this, that d1, then we have p2, and then we have d3, and then we have p1, something like this. And then let's say d2 and we have p3, something like this could be also a permutation if we follow this 6 factorial approach. So then this is wrong, this is a wrong case, right? This is a wrong case because d1 is coming, this is d1, d1 is coming before p1. Fine, it's coming before p1, hence that is wrong. First pickup should be done and then delivery should be done. So we directly cannot do this 6 factorial, right? That is 2 into n factorial. 2 into n is what, 3? So 2 into 6, 2 into 3, that is 6 factorial. This we cannot do. Fine. So now let's see how we can think of the approach. See, I'm erasing this. We understood that directly we cannot do 6 factorial to rearrange, because then this condition, this pickup delivery condition will not satisfy, right? That is one case. Okay. So see, now let's say we are doing, we have pickup, right? We have to pick up items p1, p2 and p3. So this pickup could be done in any order, right? This pickup, it's not necessary that first item will be picked up and then second item and then third item. It's not necessary. So this pickup can be done in any order. Fine, maybe it could be like p2, p1 and then p3, or it could be p3, p2 and p1. So it could be any order. Fine. So when I say it could be in any order, means how many ways we can arrange these. How many ways? So permutation comes, these are 3 items, right? So how many ways we can arrange them? 3 factorial. Fine, that is 6 ways. There are 6 ways I can arrange these p1, p2 and p3. Fine. So if you're not clear with permutation, I will highly recommend just read about permutation first. What does it mean? So basically permutation means number of arrangements. Fine, it means number of arrangements. So here, how many arrangements can be done? P1, P2, P3 could be one arrangement. This is one arrangement. This is second arrangement, and similarly for these 3 items there will be 3 factorial arrangements, that is 6 arrangements. So there will be 6 arrangements. Fine. Okay. So let's say I am picking a arrangement. I am picking, let's say I am picking this first only, P1, P2, P3, this one only. So let's say pickup is arranged in this way, P1, P2, P3. Fine. Now we have picked the items. Now we have to deliver them, right? So for this, for arranging pickups, n factorial we have done till yet, right? We have done n factorial as of now. Where n is it? N is 3, right? In the question, n is given as 3. Fine. Now see, now we have to deliver these items. That is, we have to have d1, d2 and d3. So we have to arrange these. We have to know how many ways, how many number of ways are there, so that we can arrange these deliveries and we can get the correct order, right? Correct sequence. That is, pickup is done before delivery. So see, let's say we are picking this d3. So this d3 I am picking first. Where can I put, where can I place this d3? Where can I place it? If this is the order, where can I place d3? Can I place d3 here? No. Why? Because delivery should be after pickup, right? Or can I put this d3 here? No, because again delivery is coming before pickup, which is not correct. So this d3 in this order, right? I'm talking about this order. In this order, this d3 can be placed here only after p3. So there is only one way of placing it. There is only one way of placing it. Fine. Okay, now let's see for d2. Now d3 I have placed here, right? D3 I have placed here. Now I have to place d2. So let's see where can d2 be placed. Can d2 be placed here? Here? No, because delivery cannot be done before pickup. So this is not a place where d2 can be placed. D2 we can place uh, first see, first place where we can place d2 could be here after d3. Fine. Another could be I can place it after p3, that is here, d2. Here it can be placed, right? Because pickup and then delivery. So here can be placed. Here also can be placed. That is after this pickup we are doing delivery. That is d2. So there are how many cases? One case could be, see, I'm writing the cases here. So p1, p2. Let me use another marker. So case could be p1, then p2, and then I'm placing d2 here, and then rest as such, p3 and d3. This is one way. Another way could be I'm p1, p2, then I have this p3, and then here after p3 I'm placing d2, then d3. So this is also one way. And for p1, third way could be I'm placing this d2 after d3. So p1, p2, then we have p3, and then we have d3, and then we have d2. So here at the end. So for here, here, or here. So there are how many ways? There are three ways of placing d2. Fine. So for d3 there was only one way of placing. For d2 there are three ways. Now let's see for d1. Let's see for d1. So I am taking this case. I'm taking this case for let's say we have arranged d2 after p2, right? Any arrangement you can pick up. So I'm picking this one. That is right now my arrangement is like this: p2, d2, p3, and d3. Now I have to place d1. Fine. So let's see how many ways are there. We can place d1. D1 can be placed. See, d1 can be placed here. Fine. D1 can be placed here. D1 can be placed here. D1 can be placed here. And D1 can be placed after P1 also. So how many ways are there? There are 5 ways. There are 5 ways. Fine. For example, we are writing P1 and then here we are placing D1 after pickup. And rest as such P2, D2, P3, D3. So see, this is one way of arranging pickup and deliveries. Another way could be I am placing this D1 after P2. So P1, P2, and then after placing I am placing D1 and then rest D2, P3 and D3. Fine. So in this way there will be 5 ways. 5 ways of placing D1. So guys, see now the conclusion from this discussion. Let's see the conclusion. Conclusion is that first of all we have arranged first of all what we did was we arranged these pickups, right? P1, P2, P3. So for that n factorial is the permutation, number of permutations. Then we have to arrange these deliveries d1, d2 and d3. So if first of all if we are arranging d3, so for d3 how many ways will be there? One way. For d2 how many? 3 ways. And for d1 how many? 5 ways. Now you might be thinking that I know this is a little bit confusing. You might be thinking that we have written like this p1, p2, p3 and then we are placing d3 here. So for d3 then only one way is coming. What if uh, it is like this p1, p3, p2 like this, and then we are placing d3. Then what will be the number of ways? So see guys, then number of ways will be what? Here, if this is the condition, right, then how many number of ways can be there for placing d3? We can play and let's say we have placed d2 over here, somewhere here. So how many number of ways could be there? One way here, one way here, and one way here. So there will be 3 ways again. So technically every time, it doesn't matter what the permutation is, every time For any of one delivery, one way will be there. For other delivery it will be three ways, and for other delivery it will be five ways, depending on whether which one is here. Let's say P3 is here and here it's P1. So for P3 there will be five ways, for P1 there will be three ways, and for P2 it will be one way only. That is D2 will be here only after P2. Fine. So it totally depends on the it doesn't depend on what here is pickup is here. So every time it will be 1, 3 and 5. Fine. So let's devise a formula for this. See, if see guys, if n is 1, right, that is when there is when we have to place we were placing d1, or see, let's take it as like this. So 2n minus 1 will be the number. That is, if n is 1, so how many number of ways are there? 2 into n is 1, so 2 into this will be 1. Say that is, first of all we were getting one way. Then when n was 2, that is P2. Like that, for P2 we did na. So 2 into 2 minus 1, that is 4 minus 1, which was 3 ways. Then there was coming 3 ways. And then this here 1, you can say this 1 is the number of pairs which have been placed yet. So earlier when we were placing P1, we have P1, P2, P3. We were placing D3, right? So that was the first pair. Then when D3 was placed, P1, P2, P3, and then let's say D3. Then when we were placing D2, then how many pairs will be there? 1 and this 2. So N2 means number of pairs, right? So then there will be 3 ways. And when N is 3, so 2 into 3 minus 1, that is 5 ways. Fine. So what will be the final formula for arrangements? See guys, for P1, P2 and P3, for placing, for picking the order, n factorial was there, right? Why? Because these guys can arrange in themselves. And then 1 factorial, 1 was there, 1 into 3 into 5, these number of ways was there. Fine. And this could be this could get up to 2 raised to power n minus 1. That is how many n is the number of pairs. So here also n is what? N is pairs, na, that there are 3 pairs, there are 2 pairs, P1, P1, D1, P2, D2. So 2n minus 1. So this will be the formula. This is the number of permutations for the pickup, and that will be multiplied by delivery. So this is for the first pair delivery, second pair delivery, third pair, sorry, like that, and up till 2n minus 1. Fine. So in this case, when n is 3, it will be 3 factorial multiplied by 1 into 3 into 5. Why we are multiplying 3 and 5? See guys, why we are multiplying, if you're getting confused in that. So see, these were the cases, right? These were the cases like this. So when we have something like this, let's say when we have P1, P2 and P3, then for that deliveries could be like this, D1, D2 or D3, or D2, D1 or D3. Something like this could be there, na? So for each we will have 3 cases. So that's why we multiply. If you are clear with permutations, you will get why we are multiplying. I will highly recommend, if you're not able to understand, just see what permutations is. And here 2n minus 1 is your 5. That is 2 into n is what? 3, na? 3 minus 1, that is 5. So something like this will be there. So 3 factorial will be 6 into 15. So 15 into 6 is 90. So output is 90. Fine. I hope you understood the approach. Let's see the code once. Dry run once, you will better understand. So see, what we need to do is we need to find this na n factorial and 135 up till 2n minus 1. So this is for the pickup, this is for the pickup, and this is for the delivery arrangement. These are the delivery arrangements, that is d1, d2, d3 up till dn, right, dn. And this is for p1, p2, p3 up till pn. Fine, delivery arrangements. So see, we have taken this rest variable and we have taken it long. Obviously we have to do modulus, so we have taken this modulus as well, and we are starting the loop from I to n. We have to find this factorial, right? So what we will be doing is, side by side we will be calculating the factorial. So factorial will be what? N factorial. It will be starting from 1 into 2 into 3 into 4 up till n, multiplied by, this is one thing, this n factorial, and this thing 1 into 3 into 5 into up till 2n minus 1. So here we will be side by side calculating, we will side by side calculate both of these things, that is res into what is the current I, we will multiply that, that is I if I is 1 initially, so this is multiplied, and this also we will multiply side by side, that is 2I minus 1. So this was, see, this was what, 2I minus 1, right? 2 into I is 1, so 1, that is here. And modulus we will be keep doing so that it does not exceed the limit, and at last also we'll return the this. So when I is equal to, let's say, 4, so it will be 4 multiply and 2 into I, 4 minus 1, that is 7. Fine. So we are multiplying side by side, 2 and then 3, that is if I is equal to, let's say, 2, so 2 into 2 minus 1, 3, so 2 and 3, like that we are calculating simultaneously. Fine. I hope you understood the problem and the approach. Let me know in the comments if you have any doubt. Time complexity for this is O of n. Fine, and space is constant. And yeah, let me know in the comments if you have any doubt, guys. And if you found the video helpful, please like it, subscribe to my channel, and I'll see you in the next video.